Most people think thermodynamics. Its laws and systems is an abstract subject filled with confusing equations and sign conventions. But the truth is that thermodynamics was developed to answer a brutally practical question: why some machines can convert heat into useful work while others waste most of it. Long before it became an academic subject, people were already using its logic in steam engines, furnaces, and early machines. To see this clearly, imagine a simple everyday situation where you boil water in a kettle. You supply energy in the form of heat, the water temperature rises, steam forms, and that energy leaves the system when the steam escapes. Without realizing it, you've just observed energy entering a system, being transformed, and then leaving, which is the core idea behind thermodynamics. What's actually happening here is straightforward. Energy cannot be created or destroyed, only transferred or converted, and every real process loses some usable energy as waste. Thermodynamics studies how energy flows into and out of systems, how it changes form, and why no machine can ever be 100% efficient. These ideas form the backbone of all thermodynamic laws. This same principle operates at a much larger scale in real engineering systems. Car engines convert chemical energy and fuel into mechanical work, power plants turn heat into electricity, and refrigerators move heat against its natural direction using external work. Engineers rely on thermodynamic laws to design these systems so they deliver maximum performance while minimizing energy loss. The structured understanding of thermodynamics was formalized through the work of scientists like Rudolf Clausius, who clarified the concept of energy conservation and introduced the idea that heat naturally flows in one direction, a foundation of the second law of thermodynamics. His work transformed thermodynamics from trial and error engineering into a predictable, design-driven science. Now that you understand the intuition behind thermodynamic laws and systems, the next natural step is to explore heat engines, efficiency, and entropy, where we break down why engines have limits and how engineers push those limits safely in the next episode.